Today, I'm going to introduce you to Turtlebots. Turtlebots are little robots you can program with simple code blocks. To make a Turtlebot, we use the Turtlebot tool. Scroll your mouse or press 1 on your keyboard until you find it. Right-click with the Turtlebot tool to place a Turtlebot. Right-click again on the Turtlebot to open the code editor. Inside the code editor, you can see we have a command palette on the left and a set of programs on the right. Each row is a separate program. To add code to a program, we simply click the program we want to modify, and we click code blocks to add code to that program. When you press start, the start program runs. So to make our Turtlebot do something fun, we'll click start, and we'll add some commands to our start program. Now when we press start, we'll see that the Turtlebot runs all the code that we added. Another way to start and stop Turtlebots is to use the hand tool. Scroll your mouse wheel until you get to the hand tool, click once on the Turtlebot to start, and click once again to stop. If you ever need to remove a Turtlebot, switch back to your Turtlebot tool, and then smash that Turtlebot until it breaks. Now that you know the basics, let's try and use our Turtlebots to make something cool. Over here, we have a mountain. But I'd really like to have a tunnel that goes to the other side. Instead of digging it myself, I'll have the Turtlebot do it for me. Anytime the Turtlebot goes somewhere, it removes any blocks that are in its way. So we can actually just tell the Turtlebot to go straight through the mountain. If I go to its code and I say, go straight plus 16 plus 16, that'll be a total of 33 moves in the forward direction. It'll go right through the wall and remove all the blocks that were in its way. Now, this is a great tunnel for Turtlebots, but I don't think I'm going to be able to fit in this tunnel. So instead of just going straight, why don't we make another tunnel, but make it nice and wide? We'll go with 3 blocks high and 2 blocks wide, so we have room to jump and room to scoot past another player if someone else decides to join our server. So let's add some code for that. Here in program A, we're going to go up 2, right 1, down 2, and left 1. And then when we hit start, oh, we need to call program A from our start program for anything to happen. So let's add a start program A block in our starting program, and then watch what happens. Great. That looks like the perfect shape for a tunnel to go right through this mountain. So I'm going to add another block after this that says move forward. And one step at a time, we can have our Turtlebot carve out a tunnel for us. Now, if we want to automate this process, we could say, instead of doing this, let's move this to program B. And we're going to run program B 33 times. Looks pretty good. But you know what? I think we need to move a little faster. So I'm going to pause the Turtlebot right there. I'm going to set its speed to fastest, and then I'm going to watch it go. Now that looks like a usable tunnel. So digging tunnels is great, but one of the reasons that I love playing games like this is I like to build things. And I'll show you how to do that with the Turtlebot. We'll put our Turtlebot on the ground right here, and we'll open up its code editor, and we'll look at the commands over here, which are block commands. So if we put some block commands into program A, what these are doing is they're adding blocks to the Turtlebot's block queue. Now, a queue is a data structure in programming where the first thing that you put in is also the first thing that comes out. So if we put blocks in this sequence, which is coincidentally the rainbow Roy G. Biv, the sequence that we get them out as the Turtlebot moves will also be that same sequence. So let's, for example, move up 7 times, and then in program C, let's go backwards and go down 7 times so that we get our Turtlebot back. And in start, we're going to run A, B, and C, and watch what happens. So we've loaded Roy G. Biv. We're going to move up 7 spaces, putting that rainbow right there, and then we move back down. And as we move down, you'll notice that there are no blocks being placed. Now, if we wanted to change that, we could do this. We could do program A, program B, program C, but actually, let's move the backwards motion somewhere else. So we'll do program A, load the blocks, go up. We'll go backwards, which is D, and then we'll load the blocks again, which is A, and then we'll go down, which is C. So load blocks, go up, move back, load blocks, go down. Watch what happens. Blocks in our queue start with Roy G. Biv. There we see Roy G. Biv again. We move back 2 spaces. We load up Roy G. Biv once more, but this time, because we're going in an opposite direction, they're going to come from above and go down below. This is the basis of the block queue system in Turtlebots. Now, we can use this to build a lot of really interesting structures. I'm going to do something simple right now. I'm going to build a staircase from here to the top of this mountain. I'll put a Turtlebot down. I'll jump into its command editor. I'll go to program A. Program A, I'm going to load some blocks. We're going to do a staircase that's 6 units wide, so I put 6 blocks here. In program B, I'm going to lay those blocks down. In program C, I'm going to go up and forward. In program D, I'm going to go back 6 blocks. And if in start, I say A, B, C, D, and I click start, what we'll see is we'll load the blocks, we'll put them out, we'll reset our position, and reset our position, and we're ready for the next iteration. If I hit the Turtlebot with my hand, they'll do another round of it. We can check that everything's correct, and then we can automate it. That looks pretty good to me. So in here, in program E, I'm going to say A, B, C, D, which is going to do the same thing that we did in start. And in start this time, I'm going to delete these 4, and I'm going to run program E 17 times. We're going to go to fastest, so this thing will build quickly. And then I'll step back, and we can watch the Turtlebot do its work. And it looks like we're almost to the top here, so I'm going to run up the stairs after that Turtlebot, see if I can get him turned off at just the right time. There we go. And that looks pretty good. So now, if we wanted to finish this and come down the other side, we could change the commands in the Turtlebot if we so desire. Instead of going up here on C, for example, we could go down. So add a down command, and then we'll go down 16 times again. I'll press start, and we can watch the Turtlebot do its work. So this will be the last one that went up, and now we're starting to go down. Again, I'll fly over here, and we can watch as the Turtlebot finishes its work. So there's one more thing I wanted to talk about with respect to the block queue that you can actually use for really interesting things, but it can also be kind of a gotcha if you don't know it's there. So I'm going to place a Turtlebot on the ground here, and we're going to open its code editor, and we're going to add some blocks in program A. Let's say we do kind of a rainbow sequence here just to demonstrate, and then in program B, let's move forward 4 times. And when we start the program, we're kind of going to see what we expect here. Nothing, because I didn't add programs A and B. So let's add those here and start the program again. We're going to load all these blocks into the queue that you see here. We're going to move forward 4 steps, and we've output those 4 blocks that were in the queue. Now, if we run this program again, what we might expect is to see the same 4 blocks, right? We might expect to see red, orange, yellow, and green. But in fact, what we see is we load the blocks in the queue, and the Turtlebot progresses forward, but it starts outputting cyan, blue, and purple. Why is that? Well, if we look at our queue here, we've actually loaded 7 blocks, but we've only taken 4 out. And those remaining blocks here, cyan, blue, and pink, are still in the queue. And that queue remains regardless of whether the Turtlebot stops or continues, it's always going to be there. So if we really want this to do exactly what we say and only do red, orange, yellow, and green, what we have to do first is clear the queue. And that's what this command is for, remove all blocks from your queue. Now if we do this, we're going to see that every time that we start this program, we're going to get the same blocks, red, orange, yellow, and green. We do it again, red, orange, yellow, and green. And all of the other blocks are cleared from the queue. Now, why is this kind of behavior desirable, right? Why would we want to keep blocks in the queue even though we didn't use them? So now I'm going to show you a time when you actually might not want to clear the queue if you want to generate kind of interesting artistic effects. So one thing about using the same number of moves as you have blocks is that when you do patterns, they tend to look the same. So I'm going to do an 8-block pattern here, and in B, I'm going to move in an 8-block pattern. So I'm going to move up 2 times, to the right 2 times, down 2 times, and then forward once, and to the left once. And hopefully this will put me back on solid ground when it's all done, and we'll have a little bit of a pattern that we can look at and then iterate on. All right, so we've got that sort of rainbow that ends with white right there. We'll see that this has the same pattern. We'll see that this has the same pattern again. We'll see that we have the same pattern again. And what we've done is we've kind of created this shape in the shape of colors of a rainbow that kind of does the same thing over and over again. Now, maybe instead of doing that, what we want to do is add a little bit of offset or eccentricity to that pattern. So in program A, I'm going to add a black block at the very end. And what that's going to do is it's going to offset this pattern of blocks with respect to this pattern of motion right here. So if I run A and B, it's going to run this, it's going to run this, but we're going to have this one block left over. And that's going to shift that pattern as we continue to progress forward. So watch this. We'll load our blocks. This one is going to look basically the same, but when we run the pattern again, we're going to start with black. And you see that our red block shifted. We run it again, and we're going to start with white, and our red block shifted again. We run it again, and then it shifted again. So as you can see, we're doing this kind of interesting spiral with the pattern because the length of the pattern and the length of the motion are not exactly the same. And that can create some really interesting artistic effects if used in the right way. So I'm going to set this to fastest. We're going to let it go. And we're going to watch and see what kind of pattern emerges. All right, so this is pretty cool. So if you look at our pattern from before, as you walk towards it, it's just kind of the same red, 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 orange, 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 yellow, yellow, yellow. But as we start walking along our new pattern, we can actually see it shift, and we see this rainbow kind of expressing itself not just through the blocks that we're laying out, but also linearly as this pattern progresses. And that's pretty interesting. I hope you enjoyed that introduction to Turtlebots. Everything you saw here today is 100% open source, and you'll find a link to the source code and downloads in the video description. Thanks again for watching, have a great day, and happy turtlebotting.